we're gonna take a whole review on tetration and superlogarithms. Superlogarithms are the inverse of tetration. And also, probably in this year, probably gonna learn about superroots, which is also the inverse of tetration. Let's go get back, okay? Tetration is repeated exponentiation. I'll write it over here, okay? Is repeated exponentiation. Tetration is repeated exponents. Yep, you can call it exponentiation too. Or if you can do it, repeated exponentiation is also called power towers. It's basically a tower, but it's made of powers. This is the first thing you gotta know over here. Now, second thing is that this is going to be superlogarithms, okay? So, superlogarithms is the inverse of tetration. That's the second thing you gotta know. So let's go split this up, okay? Let's go split this up. Okay? Let's go. Tetration is like this. Let me explain it with a variable. So, x tetrated to y equals x raised to the x raised to the x raised to the x many times, that is y times. For example, 2 tetrated to 3 equals 2 squared squared, which equals, you gotta evaluate it from up to down, you gotta know that too, which equals 2 squared is 4, so that means 2 squared squared is 2 raised to the 4th power, 2 raised to the 4th power equals 16. Okay? That's the first thing you gotta know about tetration. Now, second thing you gotta know is that superlogarithms is the inverse of tetration. So it should look like this: slog. Okay? Well, it's a more higher priority than logarithms, if you're confused. So let's go say, what is superlogarithm base 2 of 16? Well, it's 3 because 2 tetrated to 3 equals 16. That's how you convert it to tetration form. Okay? Let's go do another example. Let's go do the superlogarithm of base 3 of 27 equals what? Well, 3 Teterated to 2 equals 27 because 3 cubed is 27. Okay? So, to convert it, 3 Teterated to 2 equals 27. That's how you convert it to Tetration form. Okay. Now, we're gonna evaluate more Tetration if you're still confused, okay? 2 Teterated to 4 equals 2 raised to the 2 raised to the 2 raised to the 2. Evaluate it from up to down, okay? 2 squared is 4. That means 2 squared raised to the 4th power. 2 raised to the 4th power equals 16. 2 raised to the 16th power. I can break that down into 2 raised to the 8 times 2 raised to the 8. You can break it down also to 2 raised to the 4th times 2 raised to the 4th. You can also break it down 2 raised to the 4 times 2. I don't know how many times, but I'm just saying that. So you can also break that down to 2 raised to the 4th raised to the 4th power if you want to. Okay? Just do the properties of exponents reverse. Because it's gonna take you back to 16. Okay, I'm gonna do 2 raised to the 8 times 2 raised to the 8. Why? Because the properties of exponents tells us we can add the exponents. So 8 plus 8 is 16. That's why they're equivalent to each other. So 2 squared is 4. 2 cubed is 8. 2 raised to the 4th power equals 16. 2 raised to the 5th is 32. 2 raised to the 6th power equals 64. 2 raised to the 7th equals 128. And then 2 raised to the 8th is 256. Now, replace 2 raised to the 8 with 256. Do the standard algorithm. Okay? I'm going to use a dot for this one. 6 times 6 is 36. 6 times 5 is 30 plus 3, which is 33. Now, 6 times 2 is 12. 12 plus 3 is 15. I'm gonna remove this. Okay. Now, 50 has 1 0 in it. 5 times 6 is 30. 5 times 5 is 25 plus 3, which is 28. Now, 5 times 2 is 10 plus 2, which is 12. We don't want to add yet because we have one more number, which is 200. How many zeros does 200 have? 2. So we put 2 zeros over here. Multiply. 2 times 6 is 12. Now, 2 times 5 is 10. Now, 10 plus 1 is 11. Now, 2 times 2 is 4 plus 1, which is 5. Now we're going to add. 6 over here. 3 over here. 5 plus 8 is 13 plus 2, which is 15. 2 plus 2 is 4 plus 1 is 5. 1 plus 5 is 6. So, 2 Teterated to 4 equals this number over here. 65,536. That's the correct answer. It's basically repeated exponentiation. Tetration is. Now we're going to do superlogarithms. So, superlogarithms is the inverse or the reverse operation of tetration. So, for example, let's go do many ones. The superlogarithm base 4 of 256 equals to what? 2, right? 4 raised to the 4th power equals 4 squared times 4 squared. I can replace 4 squared with 16 because I know what 4 squared is. Now we're just gonna multiply. 16 times 16 gives you 256. Convert to Tetration form. 4 squared equals, 4 Teterated to 2 equals 256. Okay? Let's go do another example. Let's go do the super logarithm base 2 of 65,536. We know that 2 Teterated to 4 gives us 65,536. To convert to Tetration form, 2 Teterated to 4 equals 65,536. Now, let's go do a Tetration equation. So we just discussed one of those videos, but 2 Teterated to x equals 65,536. Well, 2 Teterated to the 1st power equals 2. And then 2 Teterated to 2 equals 4. 2 Teterated to 3 equals 16. And then 2 Teterated to 4 equals 2 raised to the 16th power, which equals 65,536. So 4 is our missing number. So that means x is 4. To show your work, just take the swag base to both sides. I want to get rid of base 2 so I can get x by itself. Now, the base 2's will cancel, giving us x equals swag base 2 of 65,536, which equals, we know that 2 Teterated to 4 equals 65,536. Let's go do another one. 4 Teterated to x equals 256. Let's go take the swag base for both sides. The 4's will cancel. X equals swag base 4 of 256. I know that 4 Teterated to 2 equals 256. One last example. 2 Teterated to x equals 16. I gotta take the swag base to both sides. And then x is swag base 2 of 16, which equals 3. That means x is 3. Bye guys! I hope you learn or review this. Bye guys! See you in the next video.